Hey Dragons, this is the review. If you've read number 1, you can see that that's the one I messed up. None of these answers are right. Did you figure out why? It's because my fellow colleagues that are laughing in the background right now didn't proofread the review like they were supposed to. So we're going to blame Mr. Aldrich and Mr. Valdez for this problem not being correct. Any comment? None. None from the Aggie. All right. So as you take a look at this one right here, which ones are false? So we're going to draw a conclusion here. All right. So we got to know this is a growth because this base is more than 1. Okay. So this one right here is going to be false because it's not a decay problem. The base is more than 1. It is a growth problem. So this one is going to be false. So our answer should include number 1. The initial number of iPads is 520. Well, my initial number is my y-intercept, or the number that is multiplied by the base. So this is my initial amount, also known as the y-intercept. So this one is true. All right, so we're going to leave that one as true. The rate of increase, remember the rate is a percent written as a decimal, so the rate is actually going to be this part right here, and that's definitely not 520, so this one is false. So 3 is false as well. Now if I would have done this right, I would have changed this one. Now, otherwise you could have answered B, but it's not. So this represents the number of months. We know number of months is time, and time is going to be our exponent right there, and that 1.0425 is not the exponent. So it's actually 1, 3, and 4 for this one right here. All right, the next one, number 2, we read this, we're given the equation. Anytime we're given an equation, what's rule number 1? That's right, put it in the calculator. All right, so if we put this thing in our calculator, I don't know why we're not seeing it, must be bad lighting. All right, so we put this in our calculator, we raise it to the x power. Well, we really don't even need it in our calculator. I'll get back to the calculator in just a second. Range, hopefully you're saying that range are the y values. That way we can get rid of this answer right here. X is for domain. All right. So all real numbers, well, if we take a look at this, this is our starting amount. And because this is a growth, because it's increasing, okay, that means that we're going to be bigger than this number right here. And if we look at our answer choices, the y's, now remember f of x has replaced y, so y is greater than this, we're going to go with D. Okay? All real numbers greater than or equal to 0 would imply that the population of Round Rock is 0. All real numbers would include negatives, and the population of Round Rock is not negative. Number 3, based on this graph, which one is true? So we're drawing lots of conclusions here. So as we take a look at this graph is happening in quadrants 1 and 2. Quadrants 3 and 4 are down here. So let's keep that in mind as we look at these answer choices. The range, or the y values, is the set of all real numbers less than 0. Well, if I have y numbers less than 0, the y's are going to be negative. And my y values are negative down here in quadrants 3 and 4. And that's not where the graph is. So this one is false. B, the domain is the set of all real numbers less than 6. No, the domain for any exponential, general exponential equation, is going to be all real numbers. So if this were gone, it would be true, but it's not. So this one, because of these last 3 characters of the sentence, makes this one false. C, the range is the set of all real numbers greater than 0. So the range is the y's. Y is greater than 0. Where are the y's greater than 0? In quadrants 1 and 2, where this graph is occurring. Answer is going to be C. Let's check just for funsies that D is wrong as well. The domain is a set of all real numbers greater than 6. Nope, the domain is the set of all real numbers. Because they say greater than 6, that makes this false. All right, we keep going. Are those crackers good, Mr. Aldrich? Yeah. All right. So this one right here, when we see a table, what do we do? What do we do when we see a table? That's right. You should put it in your calculator and do a regression. So if we put this in our calculator and do a regression, we do our stat calc 0, because it tells us that it's exponential. See right there, it tells us that it's exponential. We can check. We notice that my starting amount is 243, oh, kind of like that, and my base is repeating 3's, which just so happens to be the fraction 1/3. Let's pick D. Captain America, the coolest superhero there is. See right there, Captain, Captain America. Yeah. Okay, here we go. He deposited this amount in an account that earns 1.3% interest compounded annually. If the time is in years, which one? This is growth. All right, so you should be doing y is equal to number 1 plus r raised. This is growth. Okay, so all we got to do is know our starting amount. Well, it's all the same. That's how much you started with in the account, so that doesn't help us. It's all about the base. Well, first of all, these two aren't exponents. And because these aren't exponents, we should eliminate those guys right away. All right, so all we got to do is make sure that we add 1 to this number written as a decimal. Now remember, if we take this and divide it by 100, drop the percent sign, that's going to give me the proper decimal every time. So if I add 1 plus 0.03, we get this guy right here. Let's pick answer A. All right, so we got a toy here, and each one of the rings above it is 91% of the base. So the base, in this case, we have to realize that's our starting amount. So if we read through this, we say the diameter of the base starts out with a 10-inch diameter. So because the rings are getting smaller, we can think of this as being a decay problem. Okay, but we start with 10. So right away, we look at our answer choices. There are only 2 of them that start with the number 10. So these guys can go away. Now, remember that after we don't know the percent of decrease. We know that this, after we subtract it, is going to be 0.91. That's what 91% is. So actually, it's a 9% decrease, but they don't tell us that. They give us the actual multiplier. So if I look over here, the only one that has the right multiplier with the proper exponent is answer B. Let's go with that one. All right, let's pick the right one. Let's see, the domain, these are all exponential, so they all have the proper, so the range means that the equation has to be below this asymptote. So let's look for an asymptote of y equals 2, and let's look to see which one has the graph going below it. So because this is less than, we're going to go below the asymptote, and it should make it pretty easy as we take a look at our answer choices. The only one that has an asymptote here at 2 is this one, and the graph is below that. This one is above, goes through the asymptote of 2, so does this one. So the only one that doesn't cross the asymptote of y equals 2, remember it's a horizontal line, is this one. All right, on this one, actually it's a kind of cheesy question, because if you look at the percentage rates, you can probably match them up knowing that a lower percentage growth would mean a flatter graph, the higher percentage. So if you could do that, you'll notice that it's going to be CAB. But if you didn't, you notice that each one of these is growing, it's going up. You can put each one of these, there's my 6%, remember, write it as a decimal, add 1 to it. There's my 12%, write it as a decimal, add 1 to it, and there's my 20%. And you can see that you can match up the flatter one, the first one, the 6% is the flatter one, and the steeper one is going to be the higher percent right here. So it's a pretty cheesy question. I shouldn't have put it on the review. All right, we're getting there. Here we go. This one you really have to break out your spectacles here and be picky with the graph, okay? It says based on the information, which one appears to be true? Okay, so the number of bacteria doubled every 30 minutes. So if I go right here, that's a pretty decently clean point here. It looks like it doubles in this 30-minute span. It goes from approximately 5,000 to 10,000, but it's got to work for everyone. So what if I go for this 30-minute span? I go from 10,000 to 20,000. It still appears to double, but if you got to check the whole thing, okay? If I go this 30-minute span right here, I go from 20,000 to 35,000. That's not doubling. And so this one right here is a booby trap answer. If you just check the beginning of it, it works for the first several blocks of 30-minute chunks of time. But after a while, you get to a chunk of time where it doesn't work. All right, so let's look at the next one. Again, we really have to be careful on this. We're going from minute 195, which is right here. All right, so if I go up here to 195, that's 195, approximately 45,000. And then we're going to 210. Where's 210? It's about, again, I'm approximating this, 210, and that's approximately 65,000. All right, so the change between these 2 points is about 20,000. And now let's do the same thing from minute 120. Minute 120, we had about 10,000 bacteria, and then minute 150, we have about 20,000. That's a change of what? 10,000. So let's see if this is true. The number of bacteria gained more between 195 and 210 minutes than between 120 and 150. Is this more than this? The answer is yes. This is the one that's true. If you go through and check the other ones, you can find instances in this graph where it's false. So you got to make sure that you check all of the graph, not just a small portion of it, because you could get sidetracked. Last one, see a table, what do you do? Yeah, that's right, class, we do a regression. So we're going to put this data in our calculator, okay? So just duplicate that data. Go ahead and put it all in there. You got plenty of time. They tell us that it's exponential, so we're going to do a stat calc 0. Okay. And again, the whole reason why you do this is so that you get an equation. Now, once you have an equation, you go to your y equal button so that you can answer the question. So you can either round this to a couple of decimal places, or you can use the trick. Remember the trick if we hit the VARS button, V-A-R-S, the VARS button, and we take the statistics, which is 5. We want the equation, so we're going to arrow to the right, and we're going to press enter. It transfers all the numbers there. Now let's answer the question since we have the equation. Based on the data, which is the closest temperature after 1 hour. Now we've got to be careful here. This is in minutes, so we got to make sure that we're looking for 60, because 60 minutes is an hour. So I'm going to go to my table set, and I'm going to start at 60, and then once I go to my table, I notice that that is 72. 72. Do well.